Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. I have this 12 volt 5 ampere power supply. It is turning on, but its voltage are not regulated and not within limit. Let's check what is the problem. If you don't have good practical experience in electronics, never try to repair because there are live voltage inside. Always take care for the safety. I will apply power using series lamp. If you have isolation transformer, that is best option for your safety and equipment safety. This is the condition. The voltage are fluctuating. If I try to adjust, this is the condition. When we open it, never touch any component until we are confident that there are no voltage on this capacitor. Sometimes this capacitor holds charge and it is very dangerous. Now first we will verify voltage on this capacitor. If the voltage are higher than safe limit, above than 20-30 volt, discharge it using any lamp, any capacitor discharging kit. So this power supply is using KA3842 UC3842, the same. Either it is 3842, 2842 or 1842, the circuit is same. In this fault condition, when there is fluctuation, first checkpoint this capacitor, second checkpoint VCC capacitor for this IC. If VCC capacitor is not holding charge, it will be a reason to fluctuate. If this current sense resistor that is connected at the source pin of the MOSFET, because this IC is current mode PWM controller. So if current pulse will increase than 1 volt, this power supply will turn off and then it will reboot again. If voltage from auxiliary winding are above than the limit, this IC will go in overload protection. It will also turn off. Then it will restart again. Same way, if the voltage feedback is missing, if this feedback network is bad, or these output capacitors are weak, that will be a reason. So let's check step by step. Now our first checkpoint is this capacitor. Second checkpoint this capacitor, that is at pin number 7 of the IC VCC pin. Then we will come here in this section. These voltages are approximately stable. There is variation, there is fluctuation, but not too much. I am providing here 231 volt. 231 multiply with 1.414 to take peak voltage from this RMS voltage. That is exactly the same value. So that means this capacitor is good. That means this capacitor is safe, there is no problem. Now we will check voltage on this capacitor. It is fluctuating. If this capacitor is out of tolerance, that will be a reason to fast charging, discharging. And then VCC voltage. First we will check this capacitor, because this power supply is pre-designed. It was operative, it was working. In that condition, no need to check VCC voltage from auxiliary winding. Just we need to verify this capacitor. .47 micro, 50 volt. Discharge it. .45 micro. It's good. Now let's verify the feedback network. Optocoupler this side, here one resistor. That is 100 ohm. 100 ohm resistor, then this line is grounded. And this side, it is reaching here to this resistor, and it is reaching to output pin of TL431, center pin ground, and reference pin is connected to this resistor and here. This varying resistance is not good. Ground. Potentiometer, this end is grounded. This end is grounded. This pin is output pin. Adjust potentiometer. It is 102. 1000 ohm, and it is measuring 1100. And if we rotate it to this side to maximum, it is measuring 235 ohms. That means this potentiometer is problematic. At this point the reading must be 0, but it is reading 230 ohms. That means this potentiometer is problematic. Yes, this end is grounded. That means these 2 points are connected together, and the resistance must start from 0 to upside between ground pin and this point, because it is connected in low side. (1.2K). And if I rotate to full second side, it is measuring 270. That's wrong. It must start from 0 to 1K. And here the resistance is varying. That means this potentiometer has something wrong. (1.3K). It is reading 300 ohm more than its rated value. Now check between this pin and slider. 246 ohms. Adjust to second side, 1300. Rotate back, 200 ohms. Check with the second side, slider with second side. In this side it is measuring 1K, but here it is measuring 1.3K. That's wrong. When we check this side and this side, it is making 0. But when we check this and slider, it is not making 0. This is the problem, that this potentiometer is bad. Now I will replace this potentiometer. I have this 1 kilo ohm potentiometer. If we check the resistance at outside terminals, it is 968 ohms, 1 kilo ohm. And if we check this one, it is 1.255. Okay. If we check slider with one side, it is 361, and check slider with the second side, 611. That means the resistance is divided properly. Slider and one side, (612) from 0 ohm, 1.1 ohms to maximum. This is one side. Same time, if we check with the second side and slider, low to maximum, so it is dividing properly. I will use this one. Let's check its result. Always take care for safety. Yes, 13.86 volt. These voltages are stable now. Let's adjust it. Stable. $10.78 stable. Now I will adjust it to 12 volt. $12.00. I will connect 1 ampere load because this time we are not using heatsink. With 1 ampere, just only 11.99. That's excellent. So this was the problem, that this potentiometer was causing to fluctuate the power supply. We replaced this potentiometer and now it is working nice. If you enjoyed this video, hit the like button. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.